Welcome to another deep dive episode on the Total Space Network. I'm Mikko, and today Astro Roadie joins me to talk about Lucy.
It's Astro Roadie.
Planned to launch no earlier than October 16th, we will go over the mission in detail. You'll learn why the spacecraft is called Lucy, why the Lucy mission is going to these specific asteroids, what are the Trojan asteroids, what route will the mission take, and what science it will do and where. We will of course live stream this launch here at Total Space. Remember to join us. Let's get started. The Trojans orbit the Sun in two massive loose groups, with one group leading ahead of Jupiter in its path, the other trailing behind. These primitive bodies hold vital clues to deciphering the history of our solar system.
Lagrange points are these stable regions of space. They're around pretty much every planet in the solar system. Jupiter, by virtue of being the largest planet in the solar system, it also has the biggest Lagrange points. And these are little stable reservoirs where asteroids get in, but they never come out. In reality, what we have is sort of a snapshot of what the solar system looked like billions of years ago.
Early in the solar system, the giant planets were migrating outward, away from the sun. And at one point, there was chaos in the solar system. Some small bodies were ejected out of the solar system. Others could have been trapped in these Lagrange points. And that's one theory for how the Trojan asteroids came to be where they are today.
Why the name Lucy? The Lucy spacecraft gets its name from the fossilized remnants of a 3.2 million-year-old skeleton, AL-288-1. It is a little bit of a mouthful, so the skeletal remains are commonly referred to as Lucy, a tribute to the song Lucy in the Sky with Diamonds by the Beatles. It's reported that the song was played on repeat at the camp of the exploration site after the discovery was made. Lucy gave us a new understanding of human evolution. Much like AL-288-1, the Lucy spacecraft will hopefully allow us to better understand the origins of our solar system.
A little noisy, but I'm so excited. Lucy is going back in the sky with diamonds. Johnny will love that. Anyway, if you meet anyone up there, Lucy, give them peace and love from me.
The spacecraft. Lucy will be over 14 meters, or over 46 feet, from tip to tip, but most of that is the huge solar panels, each over 7 meters, or 24 feet in diameter, needed to power the spacecraft as it flies out to the orbit of Jupiter. Solar panels will generate 504 watts at the furthest point of the mission. This is because as it gets further away from the sun, there is less light and thus less power generated per amount of surface area of the panels. All of the instruments and the 2 meter, 6.5 feet high gain antenna needed to communicate with Earth will be located on the much smaller spacecraft body. Fully fueled, the spacecraft weighs just over 1.5 metric tons.
The instruments. Lucy's instrument pointing platform will carry 4 instruments for remote sensing science. L-Ralph is Lucy's color visible imager. The multispectral visible imaging camera, MVIC, is 0.4 to 0.85 microns. An infrared imaging spectrometer, linear etalon imaging spectral array, LISA, is 1 to 3.6 microns. LISA will allow us to look for the absorption lines that serve as the fingerprints for different silicates, ices, and organics that likely will be on the surface of the Trojan asteroids. MVIC will take color images of the Trojan asteroid targets and help determine how active they are.
LLORI, the long-range Recognizance imager, is the high spatial resolution visible imager. It is panchromatic, covering the wavelengths of 0.35 to 0.85 microns. This camera will provide the most detailed images of the surface of the Trojans.
LTES is the Thermal Emission Spectrometer. It is similar to instruments flying on OSIRIS-REx and Mars Global Surveyor. This infrared spectrometer, which is 6 to 75 microns, will allow the Lucy team to learn much more about the properties of the Trojans, such as their thermal inertia, or how well the bodies retain heat, which teaches us about the composition and structure of material on the surface of the asteroids.
Additionally, Lucy will be able to use its high-gain antenna to determine the masses of the targets using the Doppler shift of radio signals. Lucy will also be able to use its terminal tracking camera, T2CAM, to take wide-field images of the asteroids to better constrain the asteroids' shapes.
September 30th of 2015, NASA selected the Lucy mission concept, along with 4 other mission concepts to receive funding for further study. Phase A. January 4th of 2017, NASA selected Lucy as the 13th Discovery Class mission. Mars Pathfinder in 1997 was also part of this program. Phase B. October 20, 2018, NASA approved Lucy's preliminary design in the review phase. Phase C. October 21st, 2019, NASA approved the Lucy mission's detailed design in the critical design review. In August of 2020, Lucy officially began assembly, testing, and launch operations, ATLO, at Lockheed Martin Space in Littleton, Colorado. Phase D. In Q4 of 2020, construction and testing of the LLORI and LTES instruments is completed, and they are delivered to Lockheed Martin. LRALPH is completed and delivered in February of 2021. In July of 2021, Lucy spacecraft ships to Kennedy Space Center, Florida. On October 16th through November 5th of 2021, Lucy's launch period spans 21 days in the autumn of 2021. Each day, there will be a window in the morning when the spacecraft can launch. There is one more launch window next year with a slightly modified orbital path.
Mission profile. Due to launch on 16th October 2021 from Slick 41 at the Cape Canaveral Space Force Station. Lucy will launch on the Atlas V in its 401 configuration nicknamed Slick Atlas, and is due to lift off at 9:34 a.m. UTC. Lucy will be sent on an interplanetary path with gravitational slingshots using the Earth. The Lucy will travel to 7 Trojan asteroids and 1 main belt asteroid. No other space mission has been sent to as many different destinations around the Sun. It will first fly by the Earth for 2 gravity assists before it begins its journey out to the Trojan asteroids.
On its way out to the Trojan asteroids, Lucy will travel through the main asteroid belt and fly by its first asteroid in 2025, Donald Johanson, an asteroid that the Lucy team named after one of the co-discoverers of the Lucy fossil. This is a good time to take the opportunity to calibrate and test the instruments on board the Lucy spacecraft before making its way to Jupiter's lead Trojan asteroid cluster, also known as the L4 Swarm or Greek Camp. Click the card above to learn more about Lagrange Points. Here it will perform a flyby of Eurybates with its satellite, and Polymele in the fall of 2027. Flybys of Lucas and Orus will happen in 2028.
Lucy's orbit will take the spacecraft back towards Earth for another slingshot maneuver. This will take the spacecraft towards the L5 Trojans, otherwise known as the Trojan Camp. Lucy will study a binary set of asteroids, Patroclus and Menoetius, arriving there in 2033. These last 2 targets are interesting because they are the only known pairing that is not part of the much further out Kuiper belt where binary sets are actually quite common. This flyby will be the grand finale of the mission. However, Lucy will be on a stable orbit and can continue flying through the Trojan swarms for many years to come.
Sorry to interrupt the video, guys. I just wanted to say a quick thank you to our Patreon supporters. Without the dedication of these people and their support, we just could not do what we do. You can join this list of amazing people for as little as just £1 per month. Doesn't seem very much, about the price of a coffee, but makes a huge, huge difference here at Total Space. Thank you once again and enjoy the rest of your video.
Donald Johanson. Up first for Lucy on its 4 billion-mile journey is the C-type Donald Johanson. At just 2 to 3 miles wide, It's the smallest of the targets for this origin hunting spacecraft. This is considered a calibration target and will allow Lucy an opportunity to use her instruments for the first time. It will arrive in April of 2025.
We have a quick look at the asteroid types you can watch. Click the card at the top of the screen and take a look. Smash the subscribe button to see what we will bring you next.
Eurybates. Onward to her second target, Eurybates, is much larger at 40 miles wide. The C-type asteroid is a disruptional collisional family class of asteroid. While common in the main belt, this is the only known example in the Trojan swarm. Eurybates is also believed to have its own orbiting satellite, along with a field of debris, so it is a flyby one, get one free. The flyby is expected to occur in August of 2027. Then onwards for the shortest hop in the mission timeline.
Polymale. Continuing its journey through the L4 Pack of Trojans, Lucy will next stop at Polymale, the smallest of the Trojan targets for Lucy, expected in September 2027. At just 13 miles in diameter, this P-type asteroid is the same type as the much larger Patroclus and Menoetis binary bear. More about those later. This will be the first time a spacecraft has ever flown by this dark reddish class of asteroid that is believed to be rich in organics, meaning the building blocks for life rather than life in itself. Scientists think that Polymale is a collisional fragment of a larger P-type asteroid and thus will be very interesting to compare to its larger brethren.
Lucas. After visiting Polymale, Lucy will spend almost a year heading towards her date with the D-type asteroid Lucas. At 24 miles wide, it's no small target, and the spacecraft is expected to arrive in April of 2028. Due to its extremely slow rotation, the Lucas day is 446 hours long, over 18.5 Earth days. I hope the wages are good when we are mining there. Earth observations suggest this rock is elongated, pun intended, but Lucy will give us a definitive answer.
Orus. Lucy's next target is Orus. The expected flyby is in November of 2028. It's thought to be rich in organics and carbon. At 31 miles in diameter, it's comparable to size to Eurybates, but with different chemical composition and a reddish tone. We really hope the team learns a lot more here.
Patroclus and Menoetis. And last, but by no means least, the binary pair known as Patroclus and Menoetis, with an expected arrival in March of 2033. The L5 Pack of Trojans brings us another flyby get one free. Okay, I'll stop. But seriously, this is really cool, and I'm nerding out. They are both large P-type Trojans with average diameters of 70 and 65 miles respectively. It is hypothesized that the pair may unlock secrets of our planetary origins, as they may be primordial leftovers from our early solar system. Due to the high 22-degree inclination rendezvous, it is considered very difficult. But, due to a unique and complex mission profile, Lucy has a once-in-a-lifetime chance to visit the binary pair of asteroids.
Where will you be in 12 years? Do you think Lucy is the key to unlocking origins? As always, let us know what your favorite part of the Lucy mission is in the comments below. Thanks for watching this episode, and remember to check out the asteroid type video and the Lagrange point video to learn more, and see you in the next one.
Lucy was built over a 14-month period during a global pandemic.
And in fact, we will be the furthest operating spacecraft powered by solar arrays during our mission.
Thanks for watching today, and go Lucy!